Our last big topic in this module is exploring how the network can impact applications. I'll divide network faults into two main categories. First, we have soft failures that disturb the user's experience with the app. Imagine a web page loading too slowly or occasionally timing out. Then, we have situations where apps are completely dysfunctional due to a network problem, like a failed link or a misconfigured firewall rule. These are the big four issues that network engineers are constantly trying to overcome. First, we have low bandwidth. This occurs when there is congestion on a link or a node, much like a traffic jam on a road. Everything moves more slowly. Apps that require high bandwidth, such as video streaming or database synchronizing, will be especially affected. Next, we have high latency, which measures the one-way delay between two endpoints. Controlling latency is harder since we remain bound by the speed of light, so covering large geographic distances is always a challenge. Some apps like high-frequency trading systems and telephony endpoints require low latency. Jitter measures the change in latency, which can be especially damaging to interactive voice and video apps. If you have high latency, but it's consistently high, you can time when you speak and when you listen. With jitter, the latency fluctuates, making communication difficult. Last, we have packet loss. This occurs when data is simply dropped in transit without a trace. TCP-based apps can recover, but UDP-based apps may not be able to. The general solution to these problems is to implement Quality of Service or QoS, which is a software feature that can queue, schedule, and prioritize traffic according to business needs. The issues discussed previously all lead to poor user experience, but what kinds of network issues can completely break applications? Recall how NAT works. It translates network addresses in the middle of a network, allowing IPs to be obscured. Some applications may embed IP information in their payloads. Some IP telephony signaling protocols and file transfer protocols operate this way, making it difficult to work across NAT. Firewalls permit and deny traffic based on IP addresses, TCP and UDP ports, or other criteria. Many firewalls are stateful in that they remember flow information, and if your app transits a firewall, be sure that the proper ports and protocols are permitted through it. A virtual private network or VPN connection is a common technique for connecting networks together over an untrusted transport like the internet. It can also be used for remote workers to access corporate resources while at home or on travel. If your application requires VPN connectivity, be sure your VPNs are online and functional. Last, consider our load balancer that we examined in the GlobalMantics data center. The load balancer is a proxy of sorts, and imagine if it were proxying HTTP requests to the wrong servers. The users might have the web app function correctly 2 out of 3 times, but that means 1/3 of your customers will not be able to buy merchandise from your e-commerce site, as an example.